Welcome to the DIY Honda Garage channel. The DTC P0983, which stands for Shift Solenoid Valve D, open, indicates a malfunction in the electrical circuit of Shift Solenoid Valve D in the Honda CRV models from 2011 to 2016. The shift solenoid valve plays a critical role in the vehicle's automatic transmission system by controlling fluid flow, enabling the transmission to function smoothly and efficiently. It is typically located within the transmission assembly. This issue specifically relates to an electrical fault rather than a mechanical one, highlighting that the transmission's physical components are functioning as intended. Correctly diagnosing this issue is vital, as it can affect vehicle performance and lead to further complications if not resolved. Prior to beginning troubleshooting, it is crucial to record all freeze data and onboard snapshots using the Honda Diagnostic System, HDS. This will provide a comprehensive background and assist in isolating the underlying cause of the DTC P0983. The DTC P0983 points specifically to an issue with Shift Solenoid Valve D, a critical component responsible for regulating fluid flow within the automatic transmission system. This valve functions to ensure that the transmission shifts smoothly between gears, thereby optimizing vehicle performance and efficiency. Its location within the transmission assembly means that it's essential for the internal mechanics of shifting gears. If there's an open circuit, it signals that there may be a break or disconnection in the electrical path controlling the solenoid, which could lead to poor shifting performance or an inability to shift at all. It is essential to recognize that this issue arises from electrical malfunctions rather than mechanical failures within the transmission itself. Understanding the role and location of this solenoid valve is pivotal in diagnosing and rectifying any potential issues effectively. The potential causes for DTC P0983 primarily revolve around electrical circuit problems. This can include broken wires or connections leading to Shift Solenoid Valve D. It emphasizes the significance of inspecting the circuitry and ensuring secure connections throughout the harness and terminals. Poor connections can lead to intermittent signals or total loss of function for the solenoid valve, which can trigger the DTC. Loose terminals are another common issue that can lead to an open circuit condition. Each of these potential causes must be carefully evaluated during the diagnostic process to ensure comprehensive troubleshooting and resolution of the error code. When dealing with DTC P0983, symptoms may manifest as difficulties in transmission shifting. Drivers may experience hard shifts or an inability to shift into certain gears, impacting vehicle maneuverability. Additionally, the vehicle's dashboard may display warning lights, alerting the driver to transmission issues. In some severe instances, the vehicle may enter a limp mode, a fail-safe programmed into the vehicle's computer to prevent further damage during severe faults. Awareness of these symptoms is essential for drivers and technicians alike, as they provide critical indicators that point toward the need for further diagnostic analysis and potential repairs. Prompt recognition of these issues can prevent more extensive damage to the transmission system. The first step in troubleshooting DTC P0983 involves verifying the initial conditions. With the ignition switch turned to on, in this step, the technician will perform an operational check on Shift Solenoid Valve D using the HDS. This involves selecting the specific test for Shift Solenoid Valve D from the miscellaneous test menu on the HDS. As part of the testing, the technician should listen closely for any clicking sounds that would indicate the solenoid is functioning correctly. If a clicking sound is heard, it signifies that the solenoid is operating as intended, and the next steps will focus on further verification of the DTC. Conversely, if no sound is detected, That may indicate a failure within the solenoid or its circuit, which necessitates further investigation, as outlined in the subsequent troubleshooting steps. The outcome of this step is crucial for pinpointing the source of the issue. This step involves confirming the OBD onboard diagnostics status of DTC P0983 using the HDS after having started the engine again with the shift lever in park, P. The technician should closely monitor the OBD status listed in the DTC menu. If the HDS indicates a failed status for P0983, it confirms that the failure has been replicated, prompting the technician to revert to the previous diagnostic steps for a more in-depth investigation. In cases where the HDS shows a past status, it suggests that the system appears normal at that moment, although the possibility of intermittent failure remains a consideration. Factors like poor connections or loose terminals can often lead to such variability. Thus, these should be checked if this status is indicated. Finally, if the status shows as not completed, a retest while driving the vehicle may be necessary to fulfill all test conditions. This step emphasizes the importance of checking the internal resistance of Shift Solenoid Valve D. Begin by turning the ignition switch to lock 0 to ensure safety during the procedure. The technician will then use the HDS to jump the SCS selector control system line, preparing for disconnection of the necessary component. Once the ignition is off, the PCM Powertrain Control Module Connector C with its 49 pins should be disconnected to allow for accurate measurements. The technician will then measure the resistance between two specified test points, pin number 32 of the PCM connector and body ground. The acceptable range for resistance is identified as 13.8 to 17.1 ohms. If the reading falls within this range, the Shift Solenoid Valve D is deemed functional. And further steps may involve ensuring the PCM is updated or substituting it to validate performance. However, if resistance deviates, the next step is crucial for diagnosing potential wiring issues. In this step, the technician focuses on checking the continuity of the SHD, Shift Solenoid D line. This involves disconnecting the Shift Solenoid wire harness 8P connector, which separates the solenoid from the system for testing purposes. With the ignition in the lock position, the technician will proceed to check for continuity between two designated test points: the number 5 pin of the Shift Solenoid wire harness 8P and the number 32 pin of the PCM connector C. This ensures that there is a continuous electrical path, which is essential for the solenoid to function correctly. Should there be continuity, it indicates that there are no faults in the SHD wire, and the technician can progress to the next step. However, a lack of continuity suggests an open circuit somewhere along the line, necessitating repairs to restore connectivity between the Shift Solenoid harness and the PCM. This step is crucial for ensuring the integrity of the Shift Solenoid wire harness. It begins with the removal of the harness to allow for a thorough examination. The technician will check for continuity between designated points, ensuring that the wire harness connecting the Shift Solenoid Valve D and the PCM is intact and without breaks. This assessment requires disconnecting the corresponding solenoid valve connector and utilizing a multimeter to measure continuity between the specific test points. If continuity is confirmed, the technician can conclude that the wire harness is functioning correctly, leading to a decision to replace the Shift Solenoid valve itself if problems persist. Alternatively, if continuity is absent, repairs are necessary to correct any issues with the Shift Solenoid wire harness. Such diligence ensures the robustness of the vehicle's transmission system and the efficacy of the solenoid's operations. Final repair verification is an essential concluding step in the DTC P0983 troubleshooting process. After all necessary repairs have been completed, the technician should ensure that all connectors are properly reconnected to avoid any wiring issues that could lead to recurrences of the DTC. The next step involves clearing the DTC with the HDS, which allows the system to reset and confirm that the issues have been addressed. Once the DTCs are cleared, the technician should start the engine, keeping the shift lever in Park P for at least 1 second, followed by a test drive in second gear for that minimum duration. Monitoring the OBD status for P0983 during this phase is critical. A pass indication confirms that troubleshooting efforts were successful and that the system is now operating correctly without any further faults. If the status indicates a failure or remains incomplete, additional diagnostics may be necessary, suggesting that some underlying issues may not have been resolved. Preventive maintenance for avoiding DTC P0983 focuses on regular inspections and maintenance of the transmission's electrical components. Technicians and vehicle owners should routinely check the wiring associated with Shift Solenoid Valve D for signs of wear, corrosion, or damage, as these can lead to potential faults. Ensuring that all connections are secure is also imperative, since loose connections can cause intermittent issues, ultimately impacting performance. Additionally, maintaining up-to-date software in the Powertrain Control Module, PCM, can help prevent compatibility issues and ensure that the solenoid operates effectively. Implementing these preventive measures can significantly reduce the risk of encountering DTC P0983 or similar errors in the future, promoting not only reliability, but also the longevity of the vehicle's transmission system. In conclusion, DTC P0983 signifies an issue with Shift Solenoid Valve D, highlighting the need for diligent electrical troubleshooting rather than mechanical examination. This guide has outlined a comprehensive diagnosis and repair process that technicians should follow when confronted with this error code. By thoroughly checking connections, conducting resistance tests, and ensuring proper continuity, effective resolution of the issue can be achieved. Furthermore, implementing preventive maintenance measures can greatly assist in mitigating future occurrences of DTC P0983. A proactive approach can ensure optimal functioning of the transmission system and enhance the overall reliability of the vehicle. Understanding this DTC allows technicians to make informed decisions when it comes to repairs and maintenance, significantly improving customer satisfaction and vehicle performance. Please like and subscribe to the channel. See you next time.